Let me introduce you to the first lab you have to perform for this course. First of all, tell you that this is a Windows 7 virtual machine. It has a campus license, so it's legal to use it, but please do not distribute it for legal reasons, but also for security reasons, because the support for Windows 7 expired by the beginning of 2020. So it's quite likely that you can get a virus or attack in some other way if you use this virtual machine for other purposes. For the same reason, I have disabled the internet browser, but of course you can enable it again, but that's something I don't advise. Okay, so let's go to the first lab. You have the software for the three of them here. Let's get started with the first one. It uses a software by IBM called PowerProc. There are new versions of this software, but please don't use them, because the only version that works for the purposes of this course is the one from 2009, which is in the virtual machine. So don't go to the IBM site and use any newer version, because the systems supported in those new versions are not good for the purpose of this lab, because you cannot find comparable systems using the three paradigms. So starting, I accept. I will choose here Spain. Of course. And then you have the text of the lab in a document in Aula Cesga. You have to implement comparisons with three different systems. So here in the software, you will also have to choose between using individual servers for the first lab, for the first part of the lab, using a standard rack and then rackable servers, and for the third part you will use Blade Center. Actually it's one, but you will use blades there. Okay, when we are using a rack, we can choose between a Blade Center and rackable systems as these ones. You have to be sure all the time that you choose the right family of rackable systems or standalone servers, and when you implement the part of the Blade Center, you have to be sure also that you choose the right chassis and the right servers themselves. Just to show you that there are a variety of these systems. You have to choose the right one. I will go for any of them. They have to be configured properly. Every time you have to make a choice, there are some text that will help you to do that. Okay. And when you finish configuring, you can add it to the rack. In this case, I just put one chassis, and eventually you will get a spreadsheet with the characteristics. You can copy the data from here, or more easily, I think there is some kind of summary here, yep, but more easily from the spreadsheet. The spreadsheet is a Microsoft Excel 1. There is a basic version of Excel installed, but it's also a very old one, so I will advise you against using it for other purposes. Okay, remember to save the files, the spreadsheets of every part of the lab, and write them down also, so that you can make the report that you have to send me to prove that you have fulfilled the lab. Very important, make sure all the time that you are making the right choices when you have to configure the system, the processors, the memory, the switches, and so on. They should be the right ones. Okay. Now, for the second lab, the software is in this folder. You need an internet connection to fulfill this lab. The software, the piece of software is that one, hardware simulator. And before starting, you have to introduce your DNI, just the numbers. It's important that you use the correct one. I will introduce here some random numbers. Those numbers will identify you, so it's important that you put them correctly. Here it is. Okay, and this lab consists of 3 tasks. The first one is to open and examine a chassis of blades, and I will show you how it works. This is the first exercise, working with a chassis of blades. Here we have the components of the system we have to work with, and most of them are expandable. As you can see, a chassis of blades is made of blades of different kinds, power supplies, fans, interconnection modules, and the chassis itself. Okay, you have to carry out some tasks sequentially. In order to do that, you have here a list of tools, and more important, the tasks, the actions you can implement. And the logic is the following. For example, I will go just with a couple of examples. We want to take out the blade, the first one. So the first thing we have to do is to press the button, and when we try that, the action is correct, so we see a small video of person pressing that button. If the task is not correct, we don't see any reaction to that. Now, as a result of pressing the button, a lever has came out, so we have to pull the lever, or we can also do it the other way around. Take the lever and pull. And as we did it correctly, we have the action performed by this operator. In order to fill in, we have now a popping out blade that we can pull again, and we see all the action. We can go now for our kind of blade and repeat the same. Then we go with the other component, and so on. The description of what we have to do is here in the document that you can find in Aula CESGA. Some of the actions are not really that intuitive, so you have some hints, some clues about what you have to do for the first part, second, and third. The first exercise consists of taking all the components out and putting them back again. The second one works with a blade server, just one of them, and we have to remove all the components down to the microprocessor and then ensemble them again. The third one is the most complete one, consists of working with a disk enclosure. It's a chassis for disks. Overall, you will have a view of all the tasks that we have to implement in order to manage the components of a server and a disk system. And you will have a video feedback of all the tasks you have to carry out. It's very important that you pay attention to the tasks you are implementing. Try to understand the logic of all of them so that in the subsequent exercises you have the intuition needed to carry out all the other tasks. By the end of the 3 exercises, you will get a code. Write down that code and email it to me, send it to me, because that's the proof that you have finished the exercise. When I get the code, I will check that it matches your DNI, and I will use that for grading your exercise. If you are not Spanish, what you can do is using your passport number or fill it with some other number and then telling me which one you used. But please do not do the exercises with a random number that you cannot remember afterwards, because then it's going to be impossible for me to grade your exercise. Everything should work smoothly. If by accident the system crashes while you are working, well, you have to start all over again, because there is not a way to save the current state of your work. Sorry about that. Finally, the last lab, I numbered it 3, but it's quite possible that my colleague Roberto Rey assigns you a different lab in between the second and this one, but it doesn't matter much. Okay, the exercise uses some software by Hewlett-Packard. As far as I know, this is some kind of abandonware. I mean that Hewlett-Packard is not using its software, and as far as I know, the situation lasts more than 10 years, so I think we can use it legally. But again, please do not distribute this software. This piece of software allows us to work with a storage cabinet, what Hewlett-Packard calls a EVA, an enterprise virtual array of storage devices, and it's a really nice piece of software. The whole tutorial consists of 6 exercises. 3 of them are based on the hardware itself, and the other 3 are based on the administration. You can find the text of the tasks you have to carry out also in Aula CESGA, and it's very important that you pay attention to all the things you do, because then you have to fill answering these questions. When you finish, you can either fill it the electronic version of the PDF and send me the PDF, and if not, you can print it, fill it with a pencil, and at the end you take a picture of you scan the papers and email them to me. Okay, I will explain you. This piece of software shows us a view of a hardware enclosure with many disks. These are disks, and these are the controllers and switches for the network. You can see the front part or the rear part. You can also see the cables. On the right side, there is a list of tasks you have to carry out. For example, the first one is locating the power distribution unit. I know that it's accessible in the back part of the rack. It should be around here. Okay, this is. I can take a look to it. And I guess you can see a check mark here showing that I have fulfilled this task, and I can continue with the next one. Locate one of the power distribution modules. I suspect that is in the sides. Here it is. There are quite a lot, 6. I will choose any of them. Correct, I can take a look to it. Now locate the enclosure address bus shell ID expansion cable. I suspect that it should be in one of the PDMs. I will check it. This one, correct. Locate the EAB to disk drive enclosure cable. There are several cables. Something you shouldn't do is clicking on all of them, hoping to find the right one. Here it is. Click on the cable also. It's not this one. Because this is the AAB to disk, I need to find the cable that goes to the controller. Disk enclosure, this is the controller. Okay, and so on. When I finish to check all the components in this list, the software will take me to the second exercise, and then the third, and so on. It will take some time, but in this with this software you have the possibility of saving the state of your work, so you don't have to start all over if you make a pause or the system crashes. But most important, remember to write down all you have to do. So it's a good idea that you first read this paper, so you know what you are going to be asked for. And when you are carrying out the exercises, you have an idea of the things you have to pay attention to. For some of the parts, you have to change to the front view. You can do things like this, for example, removing one of the disks, putting it back again. This is one of the drive enclosures. You can click on it and see all the details. Now everything is switched off. You have to switch it on to work properly with it. You can do that in the PDU, remember. And then coming here, you can see some LEDs blinking. It's quite realistic. For example, if you remove one of the disks, in the back part you can see some lights reporting of an error, one of the disks is missing, and you can come here and press the buttons to access the diagnostics. So it's a really nice piece of software, and it helps us to learn to use one of these systems. As far as I know, despite the software is quite old, the systems didn't change much in the last year, so it's a really nice way of practicing with these components, especially because it's really impossible to use the real systems, because if any of you, for example, starts a task, that task may last several hours, and that means that no one will be able to use the system in the meantime. Whereas using a simulator, it's possible for us to let you check whatever you want, to pull a cable if you want to remove a disk, and the system will work properly for all of you anyway. So these are, I don't want to save, okay. First, I want to leave and no saving, okay. So these are the 3 labs you have to carry out for my part of this course. It will take you a bit of time. Please don't wait till the end. I will post in Aula Cesga and also in Teams the deadlines for each of them. For the first 2 ones, you have the knowledge to start them right after today, Monday the 2nd. For the For the third lab, you have to wait a bit more. And